All right, welcome back. This is Just Mr. Jones, and we're going to talk about chapter 3.5, which is talking about one-to-one and inverse functions. Okay, let's briefly review what a function is. So a function is when every x has one y. Okay. Now, a one-to-one function is kind of backwards of that. So, in short terms, this is every y has one x. Okay, and the book says that if x1 does not equal x2, then f of x1 does not equal f of x2. And that's just saying the same thing. So if we have some examples here, let's just say 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, so for just a function, every x needs to have one y. Okay. In this case, if these are my x's and these are my y's, this x here has two y's, so this is not a function. So it cannot be one-to-one. Okay. In this case, if these are my x's and these are my y's, kind of flip around, every x goes to one y. So this is a function. But notice that this y goes to two different x's. So this is not one-to-one. So this is just a function. Okay. In this case, these are my x's and these are my y's. In this case, every x goes to one y and every y goes to one x. So this we'd say is a one-to-one function. Okay. We also have what's called an onto function, and we don't talk about this very much. Okay. And an onto function means every value is accounted for. So every number is being met. Meaning if I have a 7 over here in the y column, it's not going unused. No numbers are going unused. Okay. We can test one-to-one function using the horizontal line test. Remember back when we were testing functions, we use the vertical line test. Here we have the horizontal line test. So if I draw out some functions here, and let's just look at some common ones that we look at, maybe a line, maybe a parabola, and maybe we'll have x to the third. Okay, so if I look at a horizontal line test, it cannot touch my graph anywhere more than once. So a line, linear, is a one-to-one function. However, a parabola is not, because you notice that here and here, or here and here, or here, and here it touches that horizontal line one-to-one. It is a function, but it's not a one-to-one function, and we'll talk about why that's important. Here we are a function, okay? And if I look at horizontal line test, we are one-to-one. So this here, x to the third, is a one-to-one function. Okay. And we could look at others. We could look at, what about the square root of x, which is something like that. Okay, it passes the horizontal line test. Okay, so it's fine. So the important thing about why we want to know if a function is one-to-one or not, it will determine whether the function has an inverse or not. Okay, so for an inverse, it must be one-to-one. The inverse is exactly what it said. It undoes the function. Okay, so for a picture here, let's just say I have two sets of numbers. Okay, and we will call these my x's, and we'll call these my y's. Now your f of x function is some mapping between your x's and y's, so we'll call this f of x. So really, this is your domain, and this is your range. Okay, what the inverse function will do is it will take all your y's now as your input and change your x's to the output. So this is f inverse of x. We use a little prime notation. So now these y values will become your x's, and these x values will become your y. So really your domain and range switch. Okay. Now this is algebraically what the inverse is. Okay, it is changing this equation to reverse your input and output. Now graphically what an inverse is, okay, let's say we have let's say we have this function right here. Okay, well, is it one-to-one? Horizontal line test? Well, let's check vertical line test. Yes, it's a function. Horizontal line test? Yes, it's one-to-one. So this does have an inverse. Now, because over here, your x's and y's switch spots, the same thing's going to happen here. So we actually have a reflection over the line y equals x. So if this was, we said this was f of x. Okay, if I reflect all that over y equals x, you get f prime of x, or f inverse of x. So your inverse and your original function are just a reflection across this line right here, y equals x. Okay. Now, how do I find an inverse? Other than graphically. This is how you do it graphically. But algebraically, how do we find an inverse? Well, number one, you check for one-to-one function. Okay, because if it's not a one-to-one function, then it's not going to have an inverse. Number two, you're going to switch x and y. Okay, so in your equation, you're going to switch the x and the y. And then you will solve for y. Okay, or we could put f of x. Number four, check. Now, how are you going to check? You're going to take your f and you're going to plug in. You're going to plug in x. So you're going to take your inverse, which is f to the negative 1, and you're going to plug it into f, and you should get out x. Or you can do it the other way around. You're going to plug one into the other and reduce it, and you should get an x. If you do not get an x, you did not find the inverse. Okay. And the last thing is, right, domain and range. Okay. Now remember what happened to the domain and range. So if I have f of x here, domain and range. If I have f inverse of x, domain and range, the domain of your original function becomes the range of your inverse, and the range here becomes over there. Okay, it's just a simple switch of your domain and your range. Okay, I think that will conclude it for one-to-one and inverse functions. So let's look at our questions here. So how do I find the inverse of a function? That's question one. Question two, how do the domain and range of f of x and f inverse of x relate? And number three, why is y equals x so important? Okay, and then here are your suggested problems. I will link the lesson video right here so that you can watch that if you want some more examples. Again, you can always ask me if you have more questions. This is @THS Mr. Jones signing off.